Hello students, this is a problem for IIT advanced students. The problem is like this. It's a spring extended from bottom to the top of the incline, and here is a mass just attached to the spring, not connected, just attached, just it touches it. We have to find when the body falls and falls down, how much is the maximum compression of the spring? That we have to find. The maximum compression of the spring. The body compresses the spring and reaches here. We have to find this x. Right? Why I say that this is an IIT advanced level problem? Because it involves friction, it involves Newton's laws, it involves work energy theorem. It involves three concepts. That's why I say it is an advanced level problem. So, first of all, the body is here or anywhere. What are the possible forces? For that, I have put the body here. Let me find what are the possible forces acting on this body. First of all, there is mg. It can be resolved into components again. It is theta. It is mg cos of theta. And from here, it is mg sine theta. So I have resolved this force into two pieces. And mg cos theta will be balanced by the normal reaction, because otherwise there will be a motion. This normal reaction is equal to mg cos theta. As such, there is no motion perpendicular to the plane of the incline. So when the body falls, there is a frictional force, there is a force due to the spring, there is a gravitation. There are three forces acting on the body. Spring force acts on the body, and gravitational force acts, mg sine theta acts, right? And there's also a force that you call as frictional force. Three forces are acting on the body. So step number first, let me say how many forces are acting on the body. The forces acting on the body is, first of all, gravitational force, that's mg sine theta. Number second, frictional force, that is opposite to the motion, that is upwards, that is minus mu mg cos theta, same as mu n, right? And there is what you call as spring force, that is minus kx. These are the three forces acting on the body when the body moves down from top to this level, right? So this is also theta. Now the next step is, how can we find the work done by all these three forces? So next step is work done by the forces. Done by the forces. This is the next step. When the body moves from top to this position, how much is the work done by all the three forces? So what is the work done by gravitational force? That is mg sine theta is a constant force, right, into this x. Mg is like this, x is also along the same direction, therefore it is mg sine theta into x. This is the work done by gravitational force. What is work done by frictional force? That is minus mg cos theta into same x, right? Because mu mg cos x of the plane and the body is moving down the plane, therefore this negative sign. So what is the work done by spring force? Because spring force depends upon the position, therefore you can't use the same simple formula Fs, force and displacement, force and distance equation. You can't use that formula. You have to use the formula integrated formula for work done, because here the force is variable with position. Whenever force is variable with position, the work done, as you know, should be equal to integration of F dx. This is the formula. So work done by spring force is integration 0 to x F dx, that is 0 to x minus kx dx, that is minus k, you can take out, integration of x square by 2 from 0 to x, that is minus 1 by 2 K x square. This is the work done by spring force when the body comes from here to here. Right? Now we have to use a concept, that is work done by all the forces is equal to change in kinetic energy when the body goes from one position to another position. So we can use that rule. The rule is work done by all the forces. That's called work energy theorem. Third, work energy theorem. What is work energy theorem? Work done by all the forces is equal to change in kinetic energy. Work done by all the forces is equal to change in kinetic energy. What is work done by all the forces? That is WF, WS is equal to change in kinetic energy. What is kinetic energy at position 1 and what is kinetic energy at position 2? That is, finally it stops, initially it was at rest, 0 minus 0. Finally at rest, initially it was at rest, 0 minus 0. That is mg sine theta into x minus mg cos theta into x minus 1 by 2 k x square is equal to 0. So x cancels 12. So what is x? That is, get it to the right side. It is 2 times mg sine theta minus it is frictional force, work done by frictional force is equal to mu times, yes, mu cos theta by this k. That is the answer. Here you have to take this to the right side, then you find x, it is 2 gets multiplied and k gets divided. So this is the solution of this IIT advanced level problem. It is so simple and you can do it now yourself. If you like the lecture, you can just subscribe to the channel and also share the channel for the other students so that they will also get benefited. Thank you.